Good morning, students, and how are you today? We have our lesson on direct and inverse variation applications today, word problems. So we're going to put this new skill we have to some good use. And there are some tricks here you're going to learn that are really useful for solving everyday problems, not just problems. I always talk about standardized testing and the things that you're going to see in your high school and college career, but also just those everyday problems. I've used this stuff. It's great. It's really good stuff. You're going to enjoy it. So let's start with our do now prompt. Today we're having Thankful Thursday. I think maybe a little gratitude at least once a week is a good thing. So, and you're going to think I'm really silly, but gosh, guys, it's the small things. Really, just be thankful for the place that you are now, the chair you're sitting in, if you've got quiet so you can watch the video and learn this content and make yourself a better person, just be thankful. It's a great skill. It took me way too many years to learn it, but I'm glad I understand it now. So as I said, today we're going to solve those direct and inverse variation applications. So our essential question, what are the two types of direct and inverse applications that we'll see generally? And what's a helpful hint to remember when solving a direct or indirect variation application? So as we watch the video, we've got two assigned pages today. That's 12 problems, but they are word problems. And our exit ticket is pretty much going to mirror our essential question today. What are the two types of direct and inverse variation applications, and what is a helpful hint to remember when solving a direct or indirect variation application? So tomorrow you'll have your 3 lessons and 3 homeworks due in teams. I'll set up an assignment today. Homework tonight is 18 problems. Try to get as many done as you can. If your time is short, if you're not feeling well, if you don't think you're going to finish, I wouldn't just do the first 9 and stop there. Try to do a few of each type, okay? So you've got the direct variation problems, and then you have the inverse variation problems. So make sure you get some practice with both types of problems. So remember, you know the drill, and it's starting to happen. This makes putting our camera on, connecting with each other, even if it's only a few minutes at the beginning, makes us an algebra family and really helps us to learn. So let's move on to our do now. But first, tomorrow is Superhero Day, so you can represent a real or fictional superhero as you come to class. Maybe you could have us guess who your superhero is. Friday, we have a short quiz on direct and inverse variation. I'm going to give you a little hint. Direct, inverse, or neither. Think about that. We've done some exercises like that, and that's how our quiz will look. Remember, doing your notes and your homework in real time as it's assigned is always helpful and beneficial to you. You don't want to wait until the last minute to turn everything in. So let's enjoy Thankful Thursday today. Name one thing that you like to do when you were bored. Well, what does that have to do with being thankful? A lot. If we can be thankful for the small things, it can help our overall mental health and well-being. It can help bring us joy. So as we think about, when I get bored, I love to do Sudoku. Those little Sudoku puzzles, where you have 9 numbers across, 9 numbers in the columns, and you have to get 1 through 9 in each direction. And I love, I started out with the easy ones. I love the hard ones now. But Sudoku, Mrs. Gold is thankful for Sudoku. I've seen it spelled a few different ways. I've seen this with an O. I've seen it different ways that it's spelled. But anyway, Sudoku, you know what it is. It's just a little thing I do when I'm bored. It keeps my mind sharp, keeps me from heading to the kitchen and eating too much. I think it's something I'm really thankful for. It's a little thing. But you know what? When I stop and appreciate that I have that little thing that I love, Sudoku or jigsaw puzzles, that's another one I love, I just feel better when I'm thankful. I just feel that little bit of joy inside, and it helps me to move from this minute to the next minute to the next minute with joy. So there's our exit ticket. Let's move on to our lesson. So our topic today is direct and inverse variation applications. I always tell you it's good to learn how to read cursive, especially if you ever want to research your family history. You absolutely need to know how to read cursive, guys. So you're going to look at old tombstones and old records and all kinds of old things, and they're all written in cursive, and they're kind of tricky to read. So it's a good skill to have. So here's a helpful hint. When solving a direct or inverse variation word problem, underline the two things. You're going to have two things, okay? Because direct and inverse variation is always about the relationship between two things. So assign the first thing as variable y and assign the second thing as variable x, because these problems are generally written in the way that I'm going to present them to you today. Now, also, just a little review, the constant for direct variation, okay, is y divided by x. So let's keep that in mind. So first we have a computer analyst, but this is really a wage problem. This is really about how much money this person makes. The income of a computer analyst varies directly as the number of hours worked. So income varies directly with number of hours. If the analyst earns $256 for working 8 hours, find the constant of variation. So look at my helpful hint. Assign the first thing as variable y and the second thing is variable x. Well, the first thing is income and the second thing is number of hours. So x will be my hours, y will be my income, and I know that k equals y over x. So k will equal, what is the income? $256 over, let's see, worked 8 hours over 8. And when we simplify that and divide 256 by 8, it does go into it evenly, and we get a number of 32. So what have we just figured out? We've just figured out how much money this computer programmer, how much money she makes per hour when she does this programming. So, and I've talked to you guys many times, this is not a bad career to get into. And I will tell you, as someone who has hired many computer programmers that are computer analysts, that they actually make a lot more than that now. So something to think about. Okay, let's go on to number 2. We have a water problem. The gallons of water used to take a shower vary directly with the number of minutes in the shower. So we've got gallons of water and we've got minutes. If an 8-minute shower uses 48 gallons of water, so here are our two numbers, 8 minutes, 48 gallons, find the constant of variation. So let's think about our helpful hint. Assign the first thing, gallons of water, that's going to be our y. Number of minutes is going to be our x. Let's define it. Always define your variables. So x is number of minutes, and y is how many gallons of water are used. So k equals y over x. Our y is 48 gallons. Our x is 8 minutes. And we simplify that. 48 divided by 8 is 6. So the constant of variation is 6. That means that per minute, the shower uses 6 gallons of water. So you can use this information to find out how many gallons of water a long shower would take, or how much money, going back to number 1, the analyst can make in 40 hours, a 40-hour week. So you can do those calculations once you know the constant of variation. Now with the next 4 problems, 3, 4, 5, and 6, we are going to be given some information and we're going to have to find a missing value. And to solve these problems, we're going to use our good old friend, the proportion, okay, where A over B equals C over D. Do you remember that guy? And we use cross products to solve. Everybody loves proportions. And they are very useful, very, very useful in the real world, not just in solving algebra problems. So we're going to have, this is direct variation. So we're going to have two things, okay, two things that are being compared. And let's tease out from the problem what these two things are. So number 3, it says the sales at a baseball game vary directly with the number of people attending. Okay, so what do I got going on here? I've got sales at a baseball game, sales and number of people attending. So let's just finish reading the problem. If the sales for a game are $12,000 when 800 people attend, determine how many people attend if the sales for a game are $15,000. I've got two sets of points here. So let's think about that. I have an X and a Y value. We had a helpful hint. Generally assign your first thing the Y value. That's the sales. So the number of people will be our X value. So let's put this in terms of an ordered pair. So the X value is the number of people. That's not just a hashtag. And the Y value is the sales. So we're given two sets of points with one value missing. So the first thing we have is if the sales for a game, sales 12,800 people. So that's the first point. So 800 people and the sales are 12,000. Okay, now determine how many people. Okay, so that's our missing X value. If the sales are 15,000. Okay, now we just create a proportion. So X over Y equals X over Y. So here's X, Y, X, and Y. So 12,000 over 800 equals 15,000 over X. And we just solved by cross products. So X times 12,000 equals 800 times 15,000. So 12,000 X equals, and 800 times 15,000 is 1,200,000. Okay, to solve for X, we have to divide both sides by 12,000. And when we do, X equals 1,000. Now, what does this answer mean? Let's go back to the question. If the sales for a game are 12,000 when 800 people attend, determine how many people attend if the sales are 15,000. So X equals 1,000 people. Okay, let's look at our next problem. Ounces of medication. So we're talking about medication. Maybe it's the COVID vaccine. Ounces of medication vary directly with the weight of the patient. These are our two things. We have the ounces of the medication and the weight of a patient. If a 120-pound adult requires 3/4 of an ounce of medication, how many ounces are required for a 200-pound adult? So what are we comparing? Okay, we've got our Y and our X. So we're comparing the weight of the patient with the ounces of the medication. So let's look at the information that we're given so far. So we have 120-pound adult, that's an X value, 3/4 of an ounce of medication, that's a Y value. Be careful when things are written like that. What is 3/4? 3/4 is 3/4, or it's 0.75, 0.75. So we have 120-pound adult, 3/4 of an ounce of medication. Okay, how many ounces? So this is going to be our Y, our missing Y, are required for a 200-pound adult. That's our X. So we've got 200 and Y. Now we just set up the problem. So X, Y, X, Y. So 0.75 over 120 equals Y over 200. Now we use cross products. 120 times Y is 120Y. 0.75 times 200 is 150. And we just divide both sides by 120. And Y equals 1.25. And what does that number mean? Well, let's go back to the question. How many ounces are required? So 1.25 ounces are required. So proportions are kind of easy to use. They're kind of comfortable. All right, let's try a different color for number 5. And number 5, we have a stock problem. I love these. The number of shares varies directly with the amount of dividends. Boy, that's a straightforward sentence if I ever saw one. So we've got our number of shares, which is going to be our Y value, varies directly with the amount of dividends. That's our X value. So dividends and shares. Now, if Kim owns 5 shares of stock and receives $12 per year, that's her dividend. This is the dividend. That might not be clear to you. You haven't learned about stocks yet. But the $12 a year is her dividend. How many shares of stock will she need to receive $24? So how many shares of stock is our Y, and 24 is our X in our second ordered pair. So let's set this up. We have $12 per year is our Y value for 5 shares of stock. And let's go with our unknown. We have an unknown Y for $24 in dividends. So be our Y. And let's set up our problem. 5 over 12 equals Y over 24. And to solve it, we'll use cross products. So 12 times Y is 12Y. 5 times 24 is 120. We divide both sides by 12. And Y equals 10. 10 what? How many shares of stock? 10 shares. Let's go on to number 6. So an average, acres. So it's a way to say more than 1 acre. Acreage varies directly, so that's one of our things, with the production of bushels of wheat. So let's simplify this to bushels. In a 200-acre field, 300 bushels of wheat are produced. Okay, so acreage is our Y, bushels is our X. So in a 200-acre field, that's our Y, 300 bushels, that's our X, are produced. At this rate, how many bushels, so that's an unknown X, will be produced in a 50-acre field, that's our Y. Let's define our variables. So we've got the X value is our bushels, and the Y value is our acres. So we've got 2 points. We've got our 300 bushels in a 20-acre field, and then we have an unknown number of bushels in a 50-acre field. So let's set up our problem. So it would be 20 over 300 equals 50 over x. And we'll use cross products to solve. 20 times x is 20x, and 50 times 300 is 15,000. Let's divide both sides by 20. And when we do, x equals 750. And what is our answer talking about? Well, they've asked us how many bushels. So x equals 750 bushels. Good job. Okay, now we're moving on to the inverse variation applications. So let's remember, we're going to find the constant in these first problems, and the constant for inverse variation is x times y. So let's keep that in mind as we do these next two problems. The time it takes to bake a turkey varies inversely, with the oven temperature. So we've got the time, which is our y value, and the oven temperature, which is our x value. So our x is going to be temperature, and our y is going to be time. Now, be careful when you have problems about time. This could be minutes and hours and days, but also could be weeks and years and months. So sometimes you have to do conversions when you work with problems with time. So always keep that in mind. This looks like it's a simpler problem, but I've seen lots and lots of problems where you're given something in minutes, and then the question might say how many hours, or you're given something in years, and it might say how many months. So always remember to look to see if you need to do some kind of a conversion. Okay, so if it takes 3 hours, that's our y value, to bake a turkey at 300 degrees, find the constant of variation. So k is going to equal 300 times 3, because k is x times y in inverse variation problems. So 300 times 3 is 900, and that is the constant of variation. So let's go on to number 8. The cost per person to rent a cottage is inversely proportional to the number of people who share the rent. So the cost is going to be our x. The number of people is our y. If 7 people share, and it costs $42 per person, find the constant of variation. So x is the number of people, and y is the cost, and k equals x times y, so k will equal 7 times 42, and 7 times 42 is 294. So what are we talking about? The cost. So the constant of variation there is $294. That's what it's going to cost for the 7 people to rent the cottage. I hope it's by the water, because that would make it really nice. All right, in the next 4 problems, we're going to find the missing values similar to before. We're going to have 2 points that we're working with, but instead of using cross products, we'll just set the 2 points equal to each other and multiply. So you'll see what I mean. So time traveling varies inversely with the average speed. We're not talking about time travel where you get into a machine and wake up 50 years earlier or 50 years ahead. We're just talking about going in a train or a car. In this case, it's a train. So the time traveling is the amount of time, and that's our y value, varies inversely with the average speed, and the speed is our x value. If a train travels between two cities in 3 hours at an average speed of 65 miles per hour, how long would it take at an average speed of 78 miles per hour? So the 3 hours is, well, let's define it. Let's kind of lay out our ordered pair in terms of words first. So speed is our x value, and time is our y value. So 3 hours is a y value, 65 miles is our x value, how long would it take is our missing y value, and 78 miles is our second x value. So we will have 65, comma 3, first set of ordered pairs. The second set of ordered pairs would be 78. Then we have our unknown y. So this time, remember, the constant of variation equals x times y. So we're not going to set up a cross product. What we're going to do is set these two ordered pairs equal to each other, because x times y will equal x times y, because the difference is constant. Okay, even though it's an inverse relationship, the change is steady and constant. That's why we call it a constant of variation. So simply put, we will put 65 times 3 and set that equal to 78 times y. So 65 times 3 is 195 equals 78y. To solve for y, we're going to change my color. We'll divide both sides of this problem by 78. And when we do that, y equals 2.5. And what does that answer mean? The question says, how long would it take? And this problem, the context of this problem is hours. So 2.5 or 2.5 hours it would take. Okay, welcome to our problem about laptops. We know a lot about those this year. So a company that produces laptops has determined that the number of laptops that it can sell, that's our y value, varies inversely to the price of the laptop. That'll be our x. So let's define that right now. Our x is the price, and our y is the number of laptops. Okay, so let's get into our ordered pairs. 2,000 laptops can be sold when the price is $2,500. So this is our y, this is our x. How many laptops, so that's a missing y, can be sold if the price of the laptop is $1,000? That's our second x. So let's set up our ordered pairs. We've got $2,500 and 2,000 is our first set of order pairs, the price and the number of laptops. The second set of order pairs, we want to know if the price is 1,000, how many laptops we will sell. Now, before I solve this, I want to tell you that this is a very common calculation that a manager would do in a company. And if you go on to business school and get your MBA or take business classes in college, this is very common business math. This is very real world. Managers do this all the time when they set prices for their for whatever it is that they're selling or making. This is business math 101, so to speak. So let's solve this problem. We have 2,500 times 2,000 equals, I need another zero there, equals 1,000 times y. So 2,500 times 2,000 equals 5 million. and 1,000 times y equals 1,000 y. So now we need to divide both sides of the equation by 1,000. I hope you were able to do this calculation without a calculator. I hope you got all those tricks from your 5th and 6th and 7th grade teachers. If not, maybe we should go over them in class. So we isolate y, we divide 5 million by 1,000, and we find that y equals 5,000. And what are we talking about here? The question was, how many laptops? So the answer is 5,000 laptops. So go ahead and try to identify, what's going on in number 11 and 12. See how far you get on your own and then come back to the video. All right, so for number 11, the width of a rectangle, that's our first thing we see, that will be our y, varies inversely with its length, that will be our x. If the width, y, is 4 inches when the length is 18, find the width, so our y is unknown, when the length is x. So let's use words to define this. We've got our x value is length, and the y value is width. Length and width problems are very common in algebra. So if our width is 18 and the length is 4, that's our first ordered pair. What is the width when the length is 8? So 18 times 4 equals 8 times y. 18 times 4 is 72 equals 8y. And now we need to divide both sides of this equation by 8. And y equals 9. So we don't know what the unit of measure is. They didn't tell us if it's inches or feet or miles. So we're just going to leave it at 9. So the width will be 9 when the length is 8. And lastly, number 12, we have a problem, let's see, about completing a project, another very common kind of business math project. So the number of workers varies inversely with the time in days, okay? Remember we talked about being careful with the units of measure and time to complete a project. So number of workers is our y, and in time in days is our x. So our x value is time, and our y value is the number of workers. So 5 workers, that's a y value, can complete a certain project in 24 days. That's an x value. Let me clean that up a little bit so you can see it a little better. How many workers, so that's an unknown y, will be needed to complete the project in 15 days? So let's set up our ordered pairs. First we have 24 in 5 days, or 5 workers, in 24 days. And then we have 15 days and an unknown number of workers. So at this point, I want you to stand back and look at this project. Just kind of take a common sense point of view. If 5 workers can do something in 24 days, to do the same thing in 15 days, are you going to need more or less workers? Fewer workers or more workers? Well, if you want to complete it in a shorter amount of time, you're going to need more workers. So right at the get-go, I want you to remind yourself that as I work this problem, I need to get an answer that is greater than 5. So if you come up with an answer that's less than 5, you should know right away you made a mistake and go back and rework the problem. So let's set this up. We have 24 times 5 equals 15 times y. 24 times 5 is 120 equals 15y. And now we'll divide both sides by 15. And when we do, y will equal 24 divided by 15, 8. And what are we talking about? How many workers? So y equals 8 workers. So there it is. That's your lesson on direct and inverse variation word problems. I hope you saw that they are really, really useful. So let's think about this. What are the two types of direct and inverse variation applications? Well, we've seen that we can either find a constant and that's what we did in number 1, number 2, number 7, and number 8, or we can find a missing value. And on kind of SAT, SBAC types of problems, usually you'll see the second type of problem. Now, what is a helpful hint to remember when solving a direct or indirect variation application? Okay, so underline the two things. They're always comparing two things with direct or inverse variation. It could be hours worked and the amount of money earned. It could be finishing a project with a certain number of people in a certain number of days, but underline the two things that are being compared. Okay, assign the first variable y, or the first thing, and assign the second thing as variable x. Okay, that's pretty much it. I know it's a lot to swallow, but you guys are great and you've been practicing so hard. So I just encourage you to continue to practice, work hard, be good to yourself. Know that algebra is really special, but you are even more so. So remember, as you practice, you'll be great.